All right, Foundations of Math 11. Here we go. We got our second video in our finances section. In this one, we're going to talk about loans and what are called annuities. Now, again, I am not an expert in this. I'm just going to talk about annuities in the most basic way. There are a number of different types of annuities, but the types of annuities we're going to talk about here is when you basically have a compound interest savings account, but you are also putting in fixed amounts at a given time frame. And what this does is it builds your interest on your interest and your principal, but your principal changes as well because you keep depositing more money on top of that. So think every month you deposit $200 into an account that earns you compound interest. These are the ones that really take off. Now, um, an annuity, it's a type of savings plan, and we're going to look at what are called variable annuities. So now here's an example. Find the future amount of an annuity where you have $1,000 payments and made annually for 4 years. Now, here's the long way to do that, and this is where this is going to turn into an equation after the fact. Just think about this, okay? At the end of the first year, we have deposited $1,000 into the account, and it pays 5% compound interest, but annually. So all the T values and the N values and everything doesn't make a difference. It's just 5% a year. So what we get is we get 1,000 times 0.05%. We get $50 in interest. So at the end of the year, we have $1,050. But at the end of the second year, we have more than that because we have another $1,000 we've plugged in there, right? Because every year we plug in. So now we start with $2,050 and we charge interest on that, and we end up with a new amount. And you can see that this amount now involves 50. So the $50 interest, the $1,000 principal, and the other $1,000 we've deposited. So in this case, we get an interest now of $102.50. And we add that. So for our third year, we now have $2,050 plus $102.50, but then plus that other $1,000 we're going to put in the third year. So you can see these numbers really start to take off. And what we have now is we have a new sort of principal at our third year of $3,152.50. So then for the end of the fourth year, we're going to charge 5% interest on this, and we're going to be depositing another $1,000. So you can see this really starts to accrue and build quickly. So in this case, the interest we get is now $157.63 and the additional $1,000. So at the end of this year, we end up with, after 4 years, $4,310.13. But as you can see, doing it this way is quite cumbersome. It's not very helpful. So the proof and sort of how they came up with the equation for a variable annuity is going to give it on the next slide, but it's doing this whole calculation for you in a much quicker way. And you can see how quickly your total goes up. Okay, we got up to 4310 after 4 years, and it's about $310 in interest, even though we're only making 5%. And it's because the interest is now charged on the original principal, the new payment, the principal plus interest. Everything starts to add faster and faster and faster. So here's the equation. And we got a whole bunch of letters to look at again. So in this case, F is the future amount. So it's still our amount, but it's our future amount. R is our recurring payment, big R. So if we're depositing $200 every so often, right? Or $1,000 every so often. And then R, N, and T are the same as they were in compound interest, except N doesn't technically mean compounding periods anymore, but it ties to the number of periodic payments. So if you do 4 payments a year, because you're earning interest now on the number of payments you throw in, the annual interest rate is still just an annual interest rate. So T and R are the same. So let's look at a couple examples here and you'll see how fast this grows. So find the future amount of an annuity with quarterly payments. Okay, so N is still 4. My recurring payment, quarterly payments, 600. My interest rate, 5%. And my time, 10 years. So what we're looking at is F is equal to R times 1 plus R to the N, or R over N, to the n times t minus 1, all in brackets, over r over n. Now for this one, if you're using your calculator, again, bit of strategy. So what I would do, let's plug these numbers in that we have. F is equal to 600, and then big brackets, and then you get 1 plus 0.05 divided by 4 to the power of 4 times 10. No, sorry, wrong bracket. Minus 1. Then the bracket, and then all over 0.05 divided by 4. So I would calculate a few of these out first, just to keep track of them to make your calculator work easy. So the first thing I would do is I would just go 4 times 10, 0.05 divided by 4. So if you wanted, you have 600, and then 1 plus 0.0125. And I would only do that if that calculation comes out to a relatively short decimal. Otherwise, you're going to store that. And then to the power of 40. So that's what I would definitely do first. And then on the bottom, yep, I'm going to put 0.0125. It just helps your calculator work here. So now bed mass, you're going to do 1 plus 0.0125. You're going to put that to the power of 40. You're then going to subtract 1 from that. Then you multiply by 600. So you do all of the top first, and then you divide by 0.0125. And in this case, the number that you should get for your future annuity, and if you didn't try your calculator work again, is $30,893.72. So you can see that's wild. In 10 years, $600 a month, or sorry, $600 every 4 months, quarterly, or sorry, quarterly is 4 times a year, right? So every 3 months, $600 at 5%, you're going to have almost $31,000 after 10 years. So if you think about $600 every 3 months, that's only $200 a month. That's very achievable once you start working full time, depending on your other life expenditures. So keep that in mind. That is an insane amount of money. After 10 years, you'll have 31 grand. That could potentially be a down payment on a condo. That's a new car. That's traveling for quite a long time, right? So is $200 a month really that big of a loss? Think about it, because it's not a loss. You're paying yourself, and that's why these variable annuities are amazing. So let's do another example. You're going to save up to buy a new car in 5 years, and the car is going to cost you 50 grand. So what amount must have do you have to save semi-monthly? So semi-monthly means twice a month. So if it's twice a month, that means 24 times a year, because it's twice a month and there's 12 months in a year. Okay, so what that does is, what values do we have? We have N is 24. T is 5 years. The interest rate is 6%. And we want a final value of $50,000. So this is again where the calculator gets a little bit more challenging, but let's see how we can put this together. So F is equal to, and I'm not going to write the whole equation, I'll just start plugging in money we have. R, big bracket, now 1 plus 0.06 divided by 24 to the power of 24 times 5 minus 1 all over 0.06 over 24. So let's look at this algebraically. Now remember that your future value is 50,000. So if we're going to do this algebraically, I would multiply this side by 0.06 over 24, because that's going to cancel with that, which means I'm going to multiply it over here. And if you want to try that step in your calculator right away, 0.06 divided by 24 times 50,000 is 125. So you get 125 on the left of your equation. And on the right of your equation, you just have the numerator left. So you could do this next step algebraically, but you can also do this step numerically first. Let's calculate the inside here. So I'm going to go 0.06 divided by 24. I'm going to add 1. I'm going to put it to the power of 24 times 5. So if you're putting it to the power of 24 times 5, put brackets around 24 times 5 to make sure it does that first. you should get 1.349 da 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 da. And that is being multiplied and then subtract 1. So you should get 0.349 and then repeated decimal. You're multiplying that by r. So in order to isolate r, you need to divide. So it's going to be 125 divided by that number that comes out. But do not round that number. Keep it in your calculator. So just go 125 divided by the answer button, and you should get r is equal to 357.80. So that is how much your recurring payment is going to have to be. So this is being saved semi-monthly. So it means you need to save almost 360 bucks twice a month. So that's a relatively large amount of money, but it's possible if you have a goal in mind. Sometimes the goal can justify the strategy. So again, a lot of algebra happening here or a lot of calculations. So try a couple times with your calculator. Make sure you're understanding the inputting that's going on, because understanding these calculations isn't overly complicated, but plugging them into your calculator properly is. So it's important to have a calculator. Your phone will make this very difficult. So I stress having a calculator that can store answers, has an answer button on it. I like to use the Sharp EL510. It's my favorite calculator for this basic stuff. It's relatively inexpensive. Okay, so that would be one I strongly suggest. So let's look at another example where we are comparing which annuity is the best. If you're offered a couple of scenarios, which one's going to pay you out the most? Well, so we have two scenarios here. And remember that F is equal to R big bracket 1 plus R over N to the power of N times T minus 1, all divided by R over N. So what do we have for scenario 1? We have $200 monthly, so R is 200. 4% interest rate, 0.04 monthly, so N is 12 and time is 8 years. Scenario 2, R is $100 compounded semi-monthly, so N is going to be 24. Interest rate is also 4% and time is 8 years. So the only thing that changes here, you'll notice, is the amount of payments that we put in, the compounding period. So it's 24 versus 20. And you can see that it's basically the same amount, because if it's $200 monthly versus $100 semi-monthly, it's the same amount of money, but you'll just see there's a slight variation because of the recurring payment time. So let's see what happens when we crunch this out. So F is equal to R, so 200 times 1 plus 0.04 over 12 to the power of 12 times 8, which is 96. So I'm going to plug that in right away. Minus 1, all over 0.04 divided by 12. Now, key all this through, and you'll get a future value of $22,583.71. We look at scenario 2. It's the same setup, except our 200 becomes 100. 1 plus 0.04 over 12 to the power of, this case is not over 12, because in this case we are semi-monthly, so over 24, and then to the power of 24 times 8, which is a much larger exponent, and then divided by 0.04 over 24. So in this scenario, we key this in accurately, and you'll get $22,605.66. So you can see slightly different in the answers, even though the amount of money saved is the same. $200 a month versus $100 semi-monthly is still $200 a month. But what changes, this exponent gets bigger, this ratio gets smaller, so it gives us larger values by just a little bit. And it's not a lot. If you subtract 22,605 from 22,583, it's a difference of $21.95. But it's still a difference. The whole idea is that you can see that even though the money value is the same, the number of periods changes how much money we make by, in this case, a small amount. But if your principal or your R value is larger, then obviously it's going to affect it at a bit higher scale. So be aware of those potential changes. So those are annuities. And now we're going to look at what's called financing or installment loans. These are the types of loans you'll get where you'll have to pay back the loan over a specified amount of time. Quite often you see these when you buy a vehicle. If you buy a vehicle new, they'll calculate the interest and then they'll charge you a monthly amount that gets taken right out of your bank account on a regular occurrence so that you pay the car back over a designated amount of time. Now, they'll calculate all of this for you, but it is good to understand what it is they're calculating so you don't get taken advantage of. You never want to get taken advantage of because that's not a good thing. So let's look at this example. So Raphael went to buy a new car, and the new car was $35,000. Okay, so it's going to be our p-value of some type, right? Her down payment was $3,000. And then she had to pay $838.14 a month in payments for 48 months. Okay, calculate the total cost of her car, including interest. Well, if we look at how much the car cost, $35,000 minus $3,000, because that was her down payment, her car over the 48 months, she basically owed $32,000. Now, how much interest did she pay? Well, what were her payments? Her payments were $838.14 per month, and she paid for 48 months. So how much was her total amount that she paid? Well, she paid $40,230.72 over the 48-month period. Now let me just double check that calculation. $40,230.72. So that's her total payment amount. Now, if she paid that amount and her car was $35,000, then how much did she pay in interest? Well, if you think about the fact that she put down $3,000 right off the bat, then she really only owed $32,000 as a remaining amount. And if her total payments, which started after she bought the car, amounted to that amount of money, if we subtract $32,000, we get an amount of $8,230.72. So that's how much interest she paid. Now, this was her total amount paid, but that was her total amount paid, not including her down payment. So you add the $3,000 to that, and the actual amount that she ended up paying was $43,230.72. So she ended up paying this amount. Yes, she paid $3,000 down, so it decreased the amount of interest that she ended up paying over the term of the purchase. And that's why the larger the down payment you have, the happier you can be, the better off you'll be, because you pay less interest on the amount borrowed. But if you don't have a huge down payment, just know that yes, you're going to be paying interest on whatever else you owe, but that is why you want to take advantage of low interest rates. So now let's see how that ties into how do they determine this $838 calculation? So it's when you have financing and you have set simple interest amounts. Most of the time it will be a simple interest amount over the set time frame, not a compound interest account in things like installment loans. So here's an example. New appliances for a house are $15,000. The full cost was financed over 3 years at 9% simple interest. So what's the full cost going to be? Well, first, what's the interest? Because before we know the full cost, we're going to need the interest, right? So I equals PRT. We're back to this beauty here. So the interest is going to be 15,000 times 0.09 times 3 years. So the interest charged over this purchase comes out at, crunch these numbers, and you get $4,050. So that is going to be included in the purchase price. So what they'll do is they'll take, so here's the finance charge, right? Finance charge is the fancy way of saying how much interest do you pay in order to finance this purchase. And then the installment price, well, in order to get the installment price, that's how much is this thing going to be with interest charged. So 15,000 plus $4,050 gives us a total purchase price, including interest, of $19,050, and then find the monthly payment. Well, if it's over 3 years, 3 years is 12 months times 3 is 36 months. So if this is how much it's going to cost to finance, basically take them home now and pay for them over 3 years with 9% interest, it's going to cost us $529.17. So financing is, I mean, it's pretty helpful. It's how most people live because they can't afford $19,000 or $15,000 in cash to buy a bunch of appliances. So we buy things over a certain period of time. Now, obviously, the lower the interest rate, the better it is for the buyer. If you can ever get a 0% interest, which happened a lot in the mid to late 2010s and into the early 2020s, you could take advantage of that. But if interest rates are up, then obviously be wary because you're paying more interest over a given time frame, and you don't want to pay interest if you can avoid it. So now let's look at a couple of life's brutal scenarios. Scenario one is a credit card. Now, before I get into this calculation, I just want to tell you that credit cards are amazing things. They allow you to do amazing things. You can accrue bonus rewards and all these lovely things that go along with credit cards, but they can also be absolutely brutal if you can't pay them off. Reason one, just as an example, if you have a credit card and say you have $5,000 on your credit card, you need to pay that bill off at the end of the month. And if you were to pay off $4,999, you're still short a buck. You pay the full interest amount on your credit card. So the most important lesson you could ever learn is pay off your credit card in full every time. And if you can't afford to do that, you shouldn't have bought it to begin with. And yes, hindsight is 2020, and there are emergencies, but oftentimes in our early 20s, we get a credit card and we just go on a spending spree, and then we have to pay it, and we're like, oh, I'll just pay a bit of interest. No, don't do it. It's hard to claw back from that. So just be very wary of that. Please, 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 please. So here's an example of how this works. The actual credit card calculation is incredibly complex and convoluted, but I'm going to try and break it down for you in as simple a way as possible. So the first date is actually irrelevant. On December 11th, well, it's because you have a month to pay. You accrue over a month, and then they'll give you a date to pay back. But I'm just using the example of Brad's credit card balance. Okay, his balance was $5,280, which is a scary amount to have on your credit card, but hey, it happens. And in December, he made an additional $1,235 in purchases for Christmas. That is a lot of money. Now, what that does is that gives him a credit card balance of 5280.60 plus 1235.42. That gives him a credit card balance, so basically a principal owing of $6,516.02. And you can see that he made a payment of $300. And this is where the credit card companies get you. They'll send you a bill that'll say you owe us this much money, but you only have to pay us the minimum payment, which can be a low number, and people do that. But if you do that, you get charged interest on the whole thing. So let's see what happens here. So Brad, in this example, made a payment of $300. So the new total on his credit card is $62,16.02. So that's the new total owing on his credit card. But what happens here is the monthly interest on the unpaid balance is 1.8%. Now you might be like, well, 1.8%, that's not bad at all. But that's your monthly interest payment. In order to get the yearly interest payment, you have to take that 1 plus r over n divided, or r over n to the power of n times t scenario, and crunch that. So technically we're looking at this and then minus 1. So because if you add that up, you're going to get the interest rate as a percentage of 100. So basically do this calculation to the power of 12 and then subtract 1. You get 23.8%. That's the annual interest rate. That's your R value for this credit card. But you only pay your credit card out monthly, so we break this down to a monthly percentage. But still, you're going to see that this adds up. So you pay, as I mentioned, you pay the percentage on the total. Now, the new balance is 6216 because if he paid this off before he got his bill, this is how credit cards can be complicated, right? He owed this much. He added this much to it. He paid this much. So when he gets his new bill, this is his total. So how much interest is he going to get charged on this new bill for the month of December? Well, that's his amount. And we're going to look at this in class a lot closer, but I just want you to see how these numbers can be brutal, for lack of a better word. So that's his total that he's getting charged interest on for the month of December. So his January statement is going to have this amount plus the interest he earned on that amount. So plus $111.89. So even though he paid back some money in December, depending on when he paid it back, he's getting charged interest on his new total in December. So his new bill in January comes out at $63.27.91. So you can see that that's a lot of money. And his interest rate, or his interest that he paid, is a third of the amount of money he paid back to the credit card. So that's why if you just pay back a minimum payment or an amount that is smaller than how much you owe, you're paying interest on your balance for the month. So in this case, that was his balance for the month. You're paying interest on all of it. So the interest counteracts the amount of money you paid back, and it just makes it really, really, really difficult to pay back a credit card. So if you're in any trouble and you have a large credit card bill, try and see if you can borrow some money from the bank at a lower interest rate than the credit card, and then pay the whole credit card off and leave it alone, and then pay back what you borrowed from the bank. But help get yourself out of trouble. Don't pay 23% interest at an annual rate. It's absurd, it's insane, it's nuts. If you have questions about this in class, we're going to have a good chat on credit cards, but also drop a comment in this section if you want some clarity. But credit cards can be amazing, but they can also be the detriment of many people's financial futures. And speaking of which, let's look at one of the worst types of loans you can get, and it should probably be outlawed in my opinion. And it's a payday loan. So you see places like Money Mart or Quick Money or whatever, and they're advertising payday loans. So you go in with a pay stub and they'll give you a loan. So you can borrow $300, pay $20 for a 2-week loan. So it sounds great. Look at me, they're giving me $300, but let's calculate how much interest they're actually charging you. So this is a payday loan. Interest is equal to PRT. Well, what's my principal here? My principal is $300. That's how much I'm borrowing. My interest is $20. My interest rate I don't know, and my time is weeks. So remember, 2 weeks, you need it in years. So 2 over 52. So now if you calculate these things out, 300 times 2 over 52 is 150 over 13, but then we have to divide. So really you're going 20 divided by 300 times that to get your R. And this is going to shock you. Your R value as a decimal is 1.73 repeating, which means as a percentage, it's 173.3% interest. They are charging you almost 200% interest. They are taking advantage of people who are at their weakest moment. Don't ever go to Money Mart. It is a scam. It is a huge scam. Be careful with money. If you learn anything from these videos, it's that interest can be your best friend, but can also be your worst enemy. And it depends on the context of you borrowing, saving, or and in your financial need. So be really careful. And it starts at a young age when you first get a credit card, because that can sometimes be the slippery slope that gets you down into debt. So please be careful, be careful, be careful. Let money work for you. Don't work for your money if the money is gaining interest against you. It's not where you want to be. Okay? Let that interest earn for you. Don't let that interest earn you more debt. All right? Thanks so much, and I will see you next time.